Hello everybody. Now we all know about the importance of keeping our machine data and the importance it has in the processes that we go through. We've had the ability to do this for a long time, but more and more now data has become ever more important. Today we're going to look at how data is handled on the SICK Nova platform. I'm very pleased to have Mr. Nathaniel Hofmann with me today. So Nathaniel, could you first of all begin by explaining the Nova platform? What can we achieve with this?
Well, thank you very much for having me today. I'd like to say that SICK Nova is a unique platform, software platform that's user-friendly, easy to use, and covers 2D, 3D and LiDAR devices so that customers will have a common platform to develop an application. It's interesting when you talk about data, because image data is a type of data that we all have on a day-to-day basis, because we all have mobile phones and can capture pictures. But what we can really do with industrial machine vision data to look at a process, to carry out quality control, really can unlock different applications for a customer.
Okay, that's interesting. You've got our interest. So just thinking now about people in industry at the sharp end of this, what are some of the challenges that machine vision helps them with?
There are a wide range. So process improvement, preventative maintenance, quality control, but also looking at efficiencies within the business. So there are many instances where using cameras to look at fill levels within totes or within parts of a process to optimize delivery schedules, to optimize lorry loading is one where there can be quite quick wins to minimise the wasted space which is still having to be transported. There are preventative maintenance where you can inspect the wear on certain elements within a process where if that part wears out it will fail and cause a lot of downtime in a factory. But also in terms of the end customer's experience, if you're getting a parcel or a product that looks inferior or damaged, a machine vision camera using the Nova software can look to inspect that to ensure that it's at the right quality for the customer.
Okay, that's interesting. So you're talking about real-time savings then?
Time and money, yes.
Okay, because that's a critical thing now, isn't it? A critical thing. So can you take me through? So assume I'm the end user. I'm looking at this. I'm not really sure. How do you as a company take people through the process of adoption? Where does it start?
So we at SICK, we have a very wide, broad portfolio of products, but within the machine vision portfolio that we have, the SICK Nova platform of software covers a range of cameras, 2D, 3D and LiDAR. But what we want to do is try and empower customers that want to take ownership of the machine vision tasks themselves. Because Nova is user-friendly, ultimately it allows people to develop their applications. But we want to be here as industry experts, understanding what makes the right image, understanding how to capture the right image or right data for your application. So we're here, we want to be that resource that you can bounce ideas off, but we want to empower you as a customer to take ownership of the project. But with Nova, if we train you and you know how to use Nova and your application changes, or you have more challenges within your production environment, ultimately the Nova platform allows people to change the camera, to change to use 3D, to change to use LiDAR technology, thus giving a flexible approach and a scalable approach to overcoming those challenges.
Yeah, I understood. That's interesting. So you would evaluate then, you would go in and evaluate the current process that's been looked at, and then you would produce some guidance from that?
We would work with the customer to understand the process. They know what's involved in their production process and they know where their weak points are. So we would look to work with them to identify areas where vision could improve the repeatable quality. And that would be done either on site, it could be done if there are a series of defect products, we can do feasibilities. So effectively, we want to be a flexible assistant or consultant that can help them understand where their problems are, but how vision can solve their challenges.
Excellent. Okay. Nathaniel, you've got me on the hook. I'm interested. Can we take a look at some of the products involved?
Absolutely, yes. So here we have the entry-level SICK Inspector P611 that runs the Nova software. So it's an all-in-one 2D camera but it still has a very powerful tool set. So in this application, we're looking at a cog here, we're carrying out a measurement, but at the same time, we can identify the holes and it will move around and the fixture with the tools. So this is where we start from.
Right, understood.
And then what you have in the actual Nova software is a universal display. So on the left-hand side, you have the various tools that will go down it and allow you to set up your job. In the middle, you have a live display of visual feedback, so you know if those tools are working, but also to see your pass-fail criteria. And then on the right-hand side, you have all of the various tools settings. So you can actually customize your criteria around the measurement or around the hole diameter that you need. But effectively, the unique thing about Nova is this common interface, which you'll see as we move through the product range.
Okay, let's take a look at the next product.
So here we have the latest in the SICK 2D camera range. This is the Inspector 830 with AI. It has an onboard AI accelerator to help with AI anomaly detection and AI classification. Still has the standard 2D tools, but when we look at the Nova software that's also running on this, we'll see that it's a lot of similarities, because what we can do is we can get it to identify that it's a pen, we can identify when there's nothing there, but also when there is a ball. So let me show you the Nova in action on this device.
Okay.
So here you can see, like we did before, we have the same way of building an application, the same tools. In the middle, we have a live visualization of the image with a pass-fail. We can change the product as we need and it will update itself. But on the right-hand side, in the same way you had all the individual settings and job files, again, this is where you adjust your application to suit your requirements. So it's the same look and feel across these cameras.
So basically, if I was to change cameras and I'm familiar with the platform, there's no real big learning curve.
Exactly, it's the same look and feel.
Okay, let's take a look at the next line.
So now we move into the 3D realm. We have the Visionary T Mini, which is a programmable time of flight device, but what you'll notice, this is also running the Nova software, so it still has the same look and feel. What we have here is an application where we are looking at the height of cups, trying to identify if they are all the same, so we need that height information that 3D gives us. But what we're also doing in Nova is we're looking at the completeness check to make sure that we have 6 cups in this particular example. So it would be very similar in a filling example within a packaging or a food processing where you're filling totes. So let me show you how that looks in Nova. So when we look at Nova here, we have a live image running which shows all of the cups in there, numbered 1, 2, 3, 4. This is running live because if I put my hand in there it stops. We know it's 3D because we're able to get a 3D height image of the cups in there, so we know exactly the height of them. And what we're seeing here is that it's failing because we have one that is too high. But now we're seeing but going back to what we're looking at with Nova, same build a job on the left hand side, same live image in the middle, but also the same build the application, set the tools up on the right hand side. So it has the same look and feel regardless of whether you're in 2D or 3D.
That's really interesting, thank you. Let's move on to the last one now.
So the last product I wanted to show you today was our latest SICK Ruler 3000 series. This one particularly is the Ruler 3010, which is designed for fields of view up to 100mm and has a Z accuracy of around 3 to 5 microns depending on the size field of view. We have Nova running on our SIM image processing box and communications box, but really what I wanted to show you today was what it can do with high-end 3D image processing. So we have a PCB here, we're going to pass it underneath the laser triangulation device, which is going to capture an image. It's going to capture a 3D image of the device, but what we're also going to look to do is see how Nova can work on this data. So let me show you again. So on the screen, what we have is the same look and feel as we had last time. Left-hand side is how we build our application, how we build the tools. In the middle is our live playback and live image representation, and on the right hand side we have all of the various settings that we can adjust for the specific application. But what we also have is the ability to have it as a 3D image. So now what we're able to do is zoom in on certain features within this PCB board and inspect them both in 2D for height and 3D in terms of their positioning in the X, the Y and the Z. But there is also the option of carrying out 2D image processing on the objects to carry out a fundamental 2D measurement.
So could you give us some kind of indication of the level of accuracy with something like that?
Well, this isn't the smallest one in the family. The smallest one in the family goes down to about 26mm field of view, where you're at around 1 micron. Things like vibration will affect the actual accuracy of these devices more than the resolution themselves.
Wow, that's quite impressive.
But again, the unique thing across all 4 products is the Nova image platform. So if you learn the most simplistic product and we train you and help you on that application, it becomes scalable right the way up to the top of the range 3D processing.
So that was a really good explanation of the products, and I've got it now clearly in mind. Okay, so what's the next step? If I'm watching this video today, I've got the interest, where do I start?
Well, like I say, we want to be here to help. Each application is different and every customer's problem is different. The SICK website is a great place to see our product range. However, they're individual products. So for us, it's about working with you as a customer to understand which of that products that go together to find the right solution. Nova is the common platform, but those products need to be tailored to an individual application. So please do talk to us. We're here to help. We want to understand your challenge and we want to help you to solve those industrial challenges.
Okay, that's excellent. Nathaniel, thank you very much for what you've explained. I've learned a lot from today. We really appreciate it. So if you're watching this and you would like to find out more, obviously the SICK website is a great place to start the process, but as Nathaniel made the point, it's really about collaboration and understanding the individual process there. So why not contact Nathaniel and the team here at SICK and see how they can help you. Thanks very much for watching, and we look forward to seeing you on the next video.